Hello, hello, and welcome to a little video about vertical translations of functions. All right, so here we have a nice little worked example with an original function, and this is the original function, and we also have the transformed function. Okay, now in the worked example, it says that we subtract 5 each time, so we're going down 5. And hopefully you can see that going from the f of x function, the yellow one, to the green one, we're going downwards. So we're going down 5. All right. So number 1 asks us to consider the translated function. So that's our m of x. That's our green one. Identify the slope, y-intercept of the function, and then write the equation for the function in general form. All right. Now the general form, you probably remember it back in middle school, as y equals mx plus b. Now, instead of y these days, we now use function notation, so it's f of x equals. Now, reminding ourselves, m is our average rate of change, so that's our slope. And b is our y-intercept. Okay, now our slope is the average rate of change, and we did that in our previous lessons. So let's take a look at the green function. I'm going to zoom in here, and let's see, I'm going to go left to right from one point to the other, and we'll see what the average rate of change is. So this is my point on the left, this is my point on the right. Wow, they're close. Okay, so to go from left to right, I'm going to go up 1 to the right 1. So our average rate of change, our slope, the rise is 1, the run is 1. So 1 over 1. So that's 1 over, I don't know why I wrote it that way. I've been trying to write my ones like this. So 1 over 1x plus, let's do some color coding, m. Okay. And then our y-intercept, our y-intercept is where our line crosses the y-axis. Now, we can see that on the graph right here. It looks like it is right there at -5. Or you can look at the table where x is 0. That is our y-intercept. So our y-intercept is -5, which makes our equation like this. I put a -5 instead of b. I'm going to simplify it a little bit to make it look nice. It's f of x equals 1 over 1 is 1, so 1x minus 5. Beautiful. Number 2, let's translate f of x to create a new function, p of x. So here is f of x. Letter A asks us to translate it 5 units upwards. Okay, let's do it. I'm going to use some of these points that are already labeled for us. Okay, so I'm going to go up 1, 2, 3, 4, 5. So at -2 now, for the x's, I am at 3. Okay, let's go up 1, 2, 3, 4, 5. At -1, instead of being at -1, I'm at 4. All right, then I go up 1, 2, 3, 4, 5. I was at 0 on the x's. Instead of being at 0, I am now at 5. Let's go up here. 1, 2, 3, 4, 5. At +1 on the x's, I am now at 6. And then 1, 2, 3, 4, 5. At +2, I am now up at 7. Here is, let's draw it in a different color. Let's draw it as blue. Pretend that is straight. I don't know why it came out squiggly. Okay, I'm going to just try it one more time. Oh, that was the bell. Sorry. There we go. What is the bell for? Oh, okay. Connection time. All right, so there is our p of x. All right, let's answer some questions about it. Identify the slope and y-intercept. Okay, let's check out the slope. To get from one point to the next, so from the left to the right, I'm going to go up 1 over 1. Oh, nice. We have a slope of 1 again. So let's write that down. First of all, f of x equals mx plus b. M is our slope, and it's rise over run, up 1 over 1. Oh yeah, let's color code. M, 1, 1. So 1 over 1 is 1, so I'm just going to go ahead and write 1x. Our y-intercept, that's b. There's 2 ways of finding it. right? There is looking at our table and looking at the graph. So on the graph, it's where I cross the y-axis, so it looks like it's at positive 5. Or we can look at our table, 0, 5. So 5 is our y-intercept. That's actually pretty nice. It's a positive 5, so plus 5. There's our equation. All right, let's compare f of 2 and p of 2. So essentially what I'm asking is, what is the value of the original graph at 2 and what is the value of the new graph at 2? So f of 2, let's check it out. F of 2 is right here. F of 2 is 2. And p of 2, let's see, is right here. It's 7. So how did the transformation of the function affect the value of the function at x equals 2? So what happened to go from 2 to 7 is we went up by 5. Yeah, from 2 to 7 is 5. Beautiful. Onwards we go. Number 4, consider this graph. I have considered it. Translate the graph up 4 units. And let's write an equation for it. Okay, so first what I'm going to do is I'm going to zoom in and find some nice points to use. This one is at a perfect corner, and so is this one. I'm going to use 2 points because, actually let's use 3. I'll use the y-intercept as well. Really, all you need are 2 points to graph a line, but if we have 3 nice ones, let's use the 3 nice ones. Okay, so it said up 4, let's do it. 1, 2, 3, 4. New dot. 1, 2, 3, 4. A new dot. 1, 2, 3, 4. And another new dot. Let's draw the line. Okay, we're pretending this is straight, okay? I don't know why I can't. I bet there's some tool I can use, but I'm a lazy. All right, so this is, what are we calling this one? Q of x? Okay. So we want to write the equation, all right, qx in terms of jx. Well, q of x is just j of x moved up 4. So this means j of x moved up 4. And that's what our new graph was. That's what literally number 4 asked us to do. Translate it up 4 units. Okay. What I want to do next, it has us draw another graph. Okay, let's do it. Fine, let's do it. I almost skipped a problem. That's fine. Now let's take j of x and move it down 4 units, and we're going to call it rx. Okay. So I'm going to use those same 3 points, but I'm going to go down 4. A 1, a 2, a 3, a 4. A 1, a 2, a 3, a 4. A 1, a 2, a 3, a 4. And let's use a different color this time. Let's use green. Ooh. Didn't know it was that thick. And it's called r of x. Beautiful. All right. Rx in terms of jx. Well, r of x is just j of x down 4. All right. Okay. Let's write the equations for q of x and r of x. That's what 4C is asking us. So let's do it. Q of x. Remember, it's mx plus b, right? Slope and y-intercept. And rx is also going to be mx plus b. Okay, let's check it out. Q of x, the slope, well, let's see, the slope is, I guess I'm going to use pink to find the slope. We're going to go left to right. It's up 1, 2 to the right 1. So up 2 to the right 1, that's a slope of 2. So 2x. And then our y-intercept is where I cross the y-axis. And it looks like I crossed the y-axis right here at 3. So plus 3. Wondrous. All right, let's do r of x. Same idea, let's find its slope. And that's the green one. I'm going to make this pencil thinner. There we go. All right, so to go from one point to another, I have to go up 1, 2, to the right 1. Oh, wow, they have the same slope. And then the y-intercept, let's check it out. It crosses right here, which is at -5. Okay, so -5. Okay, wonderful. And the last question that I have here about comparing the equations, what do I notice? This is really something that I'm going to ask to the class as I give this lesson. But if you were to ask just me as Guman, what do you notice, Guman? I would say, you know what? They all have the same slope, but different y-intercepts. So I'll write that down. Same slopes, different y-intercepts. Okay, and that is today's lesson. I hope you found this useful. Have a wonderful rest of whatever day it is for you. Bye!